Favorite part of the semester where we get to spend a lot of time talking about the cardiorespiratory system. Okay, so we're going to focus on the cardiovascular system this week, respiratory system next week, and then we're going to talk about how exercise affects both of these during the third week of this unit. So this unit is all cardiorespiratory. So we've got a single topic and outcome. We're just going to talk about intrinsic and extrinsic control of the heart, and really heart rate. Okay, so intrinsic control. When you hear the word intrinsic, just think about controls coming from within. Extrinsic control is coming from without, okay, or outside. So we talk about intrinsic motivation. That's motivation that you yourself create for yourself, whereas extrinsic motivation is like, hey, if you do this, I'll give you 5 points of extra credit, something like that. There's no extra credit, just to be clear, at least not right now. So intrinsic control comes from the pacemaker. Remember, pacemaker cells can generate their own action potentials, and this is great in case something goes on between the brain and the heart that disconnects that connection. So the SA node is the primary pacemaker. It has an action potential or creates action potentials between 60 and 100 times if it's not getting any outside influence. And ultimately, its job is to tell the atria to contract as well as telling the AV node, do your job. Okay, the AV node does a similar thing. It doesn't fire quite as often, but it tells the ventricles to contract, which include the bundle of His, and then the bundle of His ultimately sends signals down the bundle branches and then up through the Purkinje fibers, causing the ventricles to contract. Okay, ultimately this allows both the ventricles to contract at the same time. Then we've got extrinsic control of the heart, and this is control that's coming from outside of the heart, so in this case from the brain. So this is the autonomic nervous system involving the parasympathetic and the sympathetic nervous system. So the parasympathetic nervous system lowers heart rate. It does this by releasing acetylcholine onto the SA node and opening potassium channels, which decreases the slope of the drift, and ultimately that decreases heart rate. Now, it can get as low as into the 20s, but without any parasympathetic control, heart rate would be at least 100. So if your heart rate's ever below 100, which it probably is while listening to this video, your parasympathetic system is in charge. Now, the parasympathetic system is also what makes it possible for your heart rate to drop below 60. Remember, just a second ago, we said the SA node fires at 60 times a minute. Well, if you've got parasympathetic control, that 60 can get lower, right? And so like my resting heart rate's high 30s, low 40s, depending on the day and the amount of stress that I'm under. And so that's how that's working. I just have a lot of parasympathetic activity. Sympathetic nervous system, on the other hand, increases heart rate. It can make it go as high as 250, although that usually doesn't happen. And it's the dominant system when your heart rate is above 100. And so the way that this works is the sympathetic nervous system releases norepinephrine. It increases heart rate. It also increases stroke volume. It makes the heart contract harder. And so this response can be long lasting. The parasympathetic side only releases acetylcholine, and so releases acetylcholine, but acetylcholine only affects the SA node. It doesn't actually affect the muscle cells on the heart, and so there's no effect of the parasympathetic side on stroke volume. So, two things I hope you can do. What are the intrinsic and extrinsic factors that control heart rate?